In this video, I'm going to take you through how to list integers from inequalities. But before we do that, we've got to actually understand what an inequality means. So if we take something like this, 4 add 2, I'm sure you're all thinking, well, that's 6. And of course it is. And we could say 4 add 2 is equal to 6. However, if I put these two bits of information down, we can see that this side is 6 and this side is 11. And we could say, well, these don't equal. We could actually cross out the equal sign. But we can do more than that. We can say, well, 6 is also less than 11. And this is what we mean by an inequality. It's not equal, it's unequal. So we call it an inequality rather than an equal sign. Now, there are 4 of them. So we've got these two. Everyone knows these two, less than or greater than. And when we add these extra little bits, it sort of creates an equal sign on its side. So here and here is an equal sign rotated 45 degrees or so. So we say this left one is less than or equal to, and the one on the right is greater than or equal to. Dead easy to remember, it's pointing to the right, and if you think of a number line, numbers towards the right get bigger, and numbers heading towards the left direction get smaller. So we're going to be asked to write integers that satisfy an inequality, for example this one. Now what we mean by integers, I've put this in bold so it stands out, is a whole number. If a number has to have a decimal after it or a fraction, it's not what we call an integer. So we're looking for whole numbers, like 4 for example. So now n we are using to represent any number. So we used n to represent number. If you like, it could be a question mark there. So what numbers are less than 4? Well, 3. You could have 2, because that's less than 4. In fact, it goes on forever. So here I've written 6, but I've put the ... just to show that it does carry on forever. Let's have a look at another one. This time I've added in the equal to 3. So which numbers are more than -3, but also could be equal to -3. So because it's equal, we can start with -3, and the numbers have got to be bigger than, more than -3, so -2, -1, and we can keep going. When we swap them round, this confuses a lot of people. But if you think about it, so that's a 2, this is the less than any number. So 2 is less than the number. So what numbers are 2 less than? Well, 3, 4, 5, and so on. All of these numbers are bigger than 2, so therefore 2 is less than. And if you heard what I just said about these are bigger than 2, what we can actually do, if you don't like the way this looks, if you swap the sides over, you must swap the inequality too. So n moved to the left and the 2's on the right, so we swap the direction of the sign. And if you look, these numbers are bigger than 2, so it works. Now, because these go on forever and ever and ever, we don't often ask you this type of question. So we don't want you to keep writing until the end of time. We want a more definitive answer. So what we actually do, we put two inequalities together and ask you to list the integers or write the integers that satisfy this sort of question. So I'm going to break it down into two parts. This part first. So -1 is less than or equal to the number here. Or, like I just told you, we could swap these round, and this actually means numbers bigger than -1. So here are the numbers bigger than -1, and that goes on forever and ever and ever. But if we now take a look at this second part here, the numbers also have to be less than 4. Now we know we can't go further than here because it has to be bigger than -1, and they have to be less than 4, so these cannot be part of our answer. So let's get rid of those. So these 5 numbers are the only integers that satisfy this inequality. Now what I suggest you do now is pause the video and have a go at all of these. And when you're ready, press play. Now look at the last two, they are much more complicated, so good luck. So here we go. Top one, you should have had minus 2 to 1. Remember, it cannot include the minus 3, so it's bigger than minus 3, but it can include the 1. This one can include the 2. It's got to be bigger than 2, but less than 7. Now, what I like to do, if I'm unsure of these, I draw a number line. Now, this isn't to scale, but it's good enough to show you what I mean. So if we take this first number here, minus 4.5, that is in there. And 2.11, well, that's very close to 2. And we're only after what we call integers, whole numbers. So this isn't a whole number, but this is. And it's got to be in between these two arrows. So it's all of the integers between and including minus 4 to 2. Even if this line wasn't here, it would still include these because it was more than or equal to minus 4.5. So it's minus 4 to 2. And just pop in all the others. And the same fashion, it can include 0, but it has to be less than 4 2/3. So the nearest integer that's less than 4 2/3 is 4. So it's 0, 1, 2, 3, and 4. 4 is less than 4 2/3, so we can include it. So next video we're going to have a look at listing integers exactly the same way, but this time when there's a coefficient of n. Makes it slightly trickier, but it's nothing to worry about.